No one has ever been to space. What do you say to that? Right now, you're picturing Yuri Gagarin flying on a rocket with his famous "Let's go." Calm your imagination. Actually, it's not that simple. We're not going to talk about the moon conspiracy whose followers believe that the American Apollo program was faked. First, recall your school geography course, especially the section about Earth's atmosphere. Remember what layers make up the invisible shell of our planet. Kelu, subscribe. First, the troposphere. This is our home, which ends at an altitude of 8 to 18 kilometers, depending on the latitude. This is where cyclones and anticyclones are born, as well as the well-known atmospheric turbulence that scares people flying for the first time. The next layer is the stratosphere, which reigns at an altitude from 11 to 50 kilometers. 19th century scientists mistakenly believed that this was where Earth's atmosphere ended. Temperatures in the stratosphere are brisk, about minus 55 degrees Celsius. Remember the shocking footage from Kabul airport. Obviously, the desperate people climbing onto the fuselage of the plane had no chance of survival. Also, the ozone layer is located in the stratosphere. The ozone shield protects the planet from deadly solar radiation. And here is the mesosphere, which is located at an altitude of 50 to 90 kilometers. According to modern data, it was considered the last atmospheric layer separating Earth from space. But is that really the case? The fact is, this statement is not entirely correct. It's just a boundary that defines the differences between methods of flight. Up to an altitude of 100 kilometers, you can move using the force of air currents. But above that, only spacecraft are able to fly. In other words, there is no clear definition of exactly where Earth's atmosphere ends and outer space begins. So everyone acts at their own discretion. It turns out that neither Richard Branson nor Jeff Bezos have actually ever been to space. Yes, they just took a sightseeing flight of fantastic cost around our planet. But let's leave it to the multi-billionaires to solve their own moral dilemmas, and let's rise even higher ourselves, to the layer of the atmosphere where we are enveloped by absolute silence. It is here that molecules literally chase each other. What is this layer called? Its name is the thermosphere. It's no wonder that the hot, colorful auroras have made their home at this altitude. By the way, we passed the so-called Karman line, which is located at the boundary 100 kilometers above the Earth's surface. Some consider it the invisible boundary between Earth's atmosphere and outer space. Moreover, it is at this altitude that the upper boundary of Earth's nations is located. Beyond the Karman line, the atmosphere becomes so thin that aerodynamic aviation loses its function, and the speed required to generate lift begins to exceed the first cosmic velocity. That is 7.91 is exactly what we talked about earlier. Dividing into layers is better for selecting transportation methods than defining space boundaries. Nevertheless, reaching the Karman line is formally the main condition for recognizing a flight as a space flight. By the way, the first to cross this imaginary line were the German V-2 ballistic missiles, developed by the brilliant engineer Wernher von Braun. But let's get back to the thermosphere, or rather, let's rise a little above the Karman line, although strictly speaking, this layer begins at an altitude of 80 to 90 kilometers. The upper boundary of the thermosphere ends after passing the 700 to 800 kilometer mark. In this strange and almost silent world, flights are only possible along ballistic trajectories. Here are the radiation belts, which are extremely harmful to human health. Temperatures in the thermosphere range from minus 73 to plus 1,700 degrees Celsius. Don't be surprised. Remember the name of this layer. Why is it so hot in the thermosphere? To answer that, we need to recall some basic rules of physics. The faster particles move, the more energy they release, and accordingly, the more heat they produce. But what exactly made these particles move so fast? This process was facilitated by ultraviolet and X-rays, which, when striking the few air molecules, give them a good kick, accelerating them to unimaginable speeds. At the same time, in such an inhospitable place, you would feel freezing cold, not scorching heat. Because even though the particles carry a huge amount of energy, there are ridiculously few of them here, so the chance of encountering one is very small. Nevertheless, there are enough high-speed particles to knock down space stations. As they say, water wears away stone. So where does space actually begin, the real airless space? It would seem that it's right there in the exosphere, where the northern lights fade and absolute emptiness reigns. This is the upper part of the thermosphere, located about 1,000 kilometers above sea level. The gas here is extremely rarefied and gradually escapes into interplanetary space, which is known as dissipation, partial loss of the planetary atmosphere. At an altitude of about 3,500 kilometers, the exosphere merges with the near-space vacuum, which, as it turns out, is also not devoid of familiar particles, such as hydrogen atoms. What kind of space is this, for heaven's sake? This is where things get really interesting. At these altitudes, there is another protective layer of the Earth which captures the most harmful ultraviolet radiation and traps it as if in a prison cell. Thus, staying for a long time beyond the 500,000 kilometer mark is only possible if you are already dead and drifting aimlessly in space. But solar ultraviolet radiation isn't the only thing in the exosphere. As mentioned earlier, this space is filled with hydrogen and helium atoms, since the lightest gases rise to the top like steam over a pot of boiling water. The exosphere can boldly be called a gateway or transition between the earthly and cosmic worlds. There are actually very few particles here, but they move at tremendous speeds, sometimes reaching escape velocity. Thus, molecules can travel many thousands of kilometers before they encounter others like themselves. Let's repeat the question. Where does the exosphere end and space begin? Textbooks often mention the figure of 10,000 kilometers, but technically there is no clear boundary. So who was the first person to leave the boundaries of Earth's atmosphere and travel into space? Yuri Alexeyevich Gagarin. You'll answer in unison, and you'll be wrong, because he only crossed the Karman line, which is at an altitude of 100 kilometers. Although this doesn't diminish his achievements or make the event any less epical, but the Earth's atmosphere continues even higher. For example, most hydrogen and helium particles are found even on the moon. Listen to how the National Aeronautics and Space Administration specialists who launched the Apollo space program are sobbing. It turns out that on July 20th, 1969, Neil Armstrong and Edwin Aldrin, who visited the moon and supposedly won the lunar race, never actually entered outer space. A shocking statement, to say the least. If we examine the issue scrupulously, the geocorona, the sphere where Earth's influence extends, is located at a distance of 630,000 kilometers from the planet. That means the moon, which is 384,000 kilometers away from us, is also within this space. Oh, how many wonderful discoveries enlightenment is ready to reveal to us. Futura ultraviolet has klubti. Bojnik, diva. Korondi. As soon as the seasons change and the shining sun is replaced by gray clouds, we can observe completely different scenes. For example, when there isn't a single cloud in the sky appears light blue to us. Why does this happen? It's all about diffuse radiation. Some of the sun's rays scatter when they enter Earth's atmosphere. If this phenomenon didn't exist, when we looked up, we would just see a solid black canvas. It's also important to remember that rays scatter more if their spectral color is blue, rather than, for example, red. Our sky has different shades of blue, from dark to light. To see a delicate blue shade, go to Brazil, which has the most intense sky color on our planet. According to scientists, it's all because there aren't as many pollutants, water particles, and dust in the air over this area. We can lie on the green grass, look up, and admire the beauty of the sky. But what would you say if you saw the sky on other planets in the solar system, for example, while standing on Mars? What secrets do other planets hold, and what factors influence what the sky will look like? For us, it's what we see while being on Earth. What we can observe depends on the atmosphere of a particular planet, its density, how transparent it is, and what chemical elements it consists of. Accordingly, we might learn the color of the sky from unique footage and reconstructions. You know, not every planet in the solar system can boast an atmospheric layer. Even if it has one, it might be too thin. On a celestial body without an atmosphere, we can see everything surrounding the planet, and we aren't affected by the processes of light alteration like on Earth. The appearance of the sky also depends on certain celestial bodies. For example, on our planet, even during the daytime, we can see the moon and the sun. What would we see on Mercury? This planet is the smallest in our planetary system, and its distance from the sun is the shortest among all 8 planets. Here you are on Mercury looking up at the sky, which is a deep black color. That's because there's no atmospheric layer there. So you might think that means we'll always be able to see everything happening in space, but that's not the case. As you remember, Mercury is very close to the sun, and its glow is so bright that it outshines both stars and other space objects. That's why you can't see any of this during the daytime. Moreover, the fact that Mercury and the sun are relatively close to each other means that the main star of our planet appears much larger than it does from Earth. And the brightness of sunlight on Mercury can be 10 times higher than on our home planet. While on Mercury, we would be able to see Venus more clearly, whose glow appears brighter, as well as Earth and our moon. Venus, by contrast, has a thicker layer in its sky. The main difference between this planet and Mercury is that it has an atmosphere. Its thickness is about 20 kilometers, and its composition includes sulfuric acid, which forms that impenetrable cloud cover. Because of such a sky, it's much darker on Venus during the day than on our home planet, even though it's closer to the sun. To better understand what the sky looks like on Venus, imagine the weather on Earth right before it's about to rain. As you can imagine, because of the thick layer of sulfuric clouds on Venus, we wouldn't be able to see the clear outlines of planets, stars, and other celestial objects. In 1961, the Soviet Union launched the Venera program, which lasted until 1983. During this operation, scientists discovered that the color of Venus's sky is an orange-red shade, and sometimes it can be yellow-green. If the planet didn't have such a dense atmosphere, it would be easy to see the Earth with its satellite and the sun in detail from there. So what would the sky look like on the moon? It has a lot in common with the sky over Mercury. For example, neither of them has an atmosphere, so the color of the sky there is distinctly black. The difference is that on the moon, you can't see the stars during the day because of the bright sunlight. Also, the main star of our system looks different on Earth and on the moon, even though the sun appears to be the same size in both places. On our satellite, it will appear brighter and its shade will be closer to white. As you can imagine, on the moon we can see our home planet very well. This is confirmed by images obtained during space expeditions. The Earth appears much larger from the moon than the moon does from the Earth. Its diameter is 4 times greater than that of our satellite. The sky over Mars, the so-called red planet, is of particular interest. As with Venus, Mars has an atmosphere, but its layer is very thin, and it also contains a lot of dust. Because of this, we observe that the sunlight is strongly scattered there. Therefore, visibility on the red planet is no better than on Venus. Even during the day, you can't see the stars there. So what color is the sky on Mars? It turned out that it's not so easy to determine this in practice. There's a high level of aerosol in the atmosphere, but that's not the only reason. This is also influenced by the so-called Purkinje effect, a phenomenon where the color perception of objects changes as the lighting decreases. That's why what our eyes see depends on the level of brightness. If its level decreases, red shades appear much darker, while at the same time we can still see blue regardless of the lighting. Now we can say for sure that during the daytime the Martian sky is red and sometimes leans toward orange. As sunset approaches, the shade turns pink, and when the planet is close to the main star, during sunset the sky becomes bright blue. The images that scientists received during the Mars expedition do not always accurately reflect the true color palette of the sky. This is because in many photos, reality is distorted by filters that researchers use to better observe certain details. Even so, you will surely agree that the view of the sky on the red planet is breathtaking. The enchanting sky can also be seen on Saturn, the ringed planet. The presence of a ring system made of rock and ice is one of the features of this planet. Accordingly, they can be seen from the surface of Saturn. If we found ourselves on this planet, the rings would appear to us as huge arcs. But it's not only Saturn's rings that deserve our attention. In areas of the planet where there are elevations, the sky is a distinct blue color, and in some places a yellowish tint can be observed. A large number of moons are located close to Saturn, of which just over 80 are known. If we are amazed by how beautiful and breathtaking the view of the moon is from our planet, we can't even imagine how enchanting the view must be on Saturn, which has several dozen moons. However, in reality, the view is not as spectacular as we might think. Most of the ringed planet's moons are small and can't be seen at all, and the largest ones, like Titan, are too far away. That's why it is. But on Saturn, it seems much smaller than the moon does on Earth. Anything can get lost. It's hard to argue with that statement. Keys, earrings, headphones, and pens are the current top lost items. But here's the question. Can an entire planet get lost? Is it really possible for a huge rocky gaseous or icy body to just disappear somewhere? It turns out yes. Planet X is a clear example. Scientists have been searching for it without success since the mid-19th century. But why did astronomers come up with the idea of an invisible planet? The first reason is the abnormal deviation of the orbits of gas giants like Uranus and Neptune. This aspect was pointed out in the early 20th century by Percival Lowell, an American astronomer who, among other things, studied the planet Mars in detail and researched asteroids. And even earlier, in the 1840s, Urbain Le Verrier, a French mathematician, thought about something similar. In other words, something large and invisible to us, presumably planets, is influencing the bodies of the solar system with its own gravity. Therefore, when Clyde Tombaugh discovered Pluto in 1930, the scientific community rejoiced. Astronomers believed that this planet was responsible for the distortion of the orbits of our gas giants. Of course, later on, the supporters of this theory faced a harsh disappointment. Pluto turned out to be far too insignificant to noticeably affect celestial bodies of such enormous size. But the issue was only discovered in 1978, after the discovery of Pluto's moon Charon. It was then that the true parameters of what was once the smallest planet in the solar system were revealed. And in 2006, Pluto was completely expelled from the ranks of planets and classified as a dwarf object. So where is it? The real Planet X? This name can rather be considered a collective term, since in astronomical circles this term is used for any undiscovered celestial body in the outer part of the solar system. On the other hand, there's a certain wordplay hidden in the name. The thing is, X is always perceived by people as the unknown, but it can also be the Roman numeral 10, meaning the 10th planet if you count Pluto. Since many scientists believe in the existence of a hypothetical object, they try to imagine what it looks like. What parameters of Planet X have been mentioned during this time? French physicist Jacques Bobigny hypothesized that Planet X, or Hyperion, is 12 times more massive than Earth. And the scientist Gabriel Delay announced the conclusion that the trans-Neptunian planet is located about 47 astronomical units from the Sun, and from there influences Uranus's orbit. At the same time, the well-known debater Thomas Jefferson Jackson C. decided that there are actually 3 planets, and he named one of them Ocean. An interesting hypothesis was also put forward by the astronomer of Indian descent Venkatesh Kitkar, based on the complex resonance of Jupiter's inner Galilean moons. He suggested that Uranus and Neptune are connected by a similar process with 2 trans-Neptunian objects. One of the planets that Kitkar talked about was discovered 19 years later, and it turned out to be Pluto. The second one, called Vishnu by the scientist, still hasn't been found. Perhaps this is the very Planet X. In any case, none of the hypotheses have been confirmed so far. Besides the ones mentioned, there is another interesting theory concerning Planet X. It is about the Kuiper Gap. As is known, beyond Neptune's orbit, there is an asteroid belt with that name. While studying it, a curious phenomenon was observed. The integrity of the belt suddenly breaks off at a distance of 48 astronomical units from the Sun. This may be caused by the presence of an object with the mass of Earth or Mars. When astronomers tested this theory, it turned out that if a planet like that were located at such a distance, the configuration of trans-Neptunian objects would be completely different from what we observe now. Because of this, specialists adjusted the distance of the hypothetical celestial body and predict that Planet X is located more than 100 astronomical units from the Sun. So where is it really? It's an elusive and mysterious planet. If we combine all the existing hypotheses, we can sketch out its portrait schematically. It's a celestial body with a mass 5 to 15 times greater than Earth's, located at a distance of 45 to 150 billion kilometers from the Sun. Actually, that's exactly what explains its elusiveness. The planet receives too little light from our star, so it has little chance of being detected by Earth-based telescopes. But is that really the case? The latter claim was recently debunked by astrophysicists James Anvin and Jakub Stolz, who work at Durham and the University of Illinois in Chicago. They think Planet X is hard to find, not because it's far from the Sun, but because it's actually a black hole, not a planet. However, it's very small, Scientists claim that this vortex is surrounded by clouds of dark matter, which of course makes it impossible to observe visually. The only thing that gives away the mysterious object is gamma radiation. The Fermi telescope, which specializes in gamma bursts, has been monitoring the sky since 2008. If it manages to detect bursts slowly moving across the sky, then the theory about the black hole can be considered confirmed. Will scientists ever run out of imagination? Maybe in the future they will give up the search, but for now, astronomers keep coming up with ideas about what Planet X could be. That's why it's worth mentioning a few more hypotheses. First of all, there's a gas giant called Chucky, which is supposedly located in the Oort cloud. John Mattis and Daniel Whitmer from the University of Louisiana believe that to prove the existence of this planet, it's necessary to open the archives of the Wide Field Infrared Survey Explorer Telescope, which was launched into orbit in 2009 by National Aeronautics and Space Administration as space agency. It's noteworthy that several years after this hypothesis was proposed, National Aeronautics and Space Administration specialists stated that the possibility of a gas giant existing at a distance closer than 10,000 astronomical units is completely ruled out. At the same time, the group of scientists who made this hypothesis public claims that Chucky exists. Moreover, right now, it is actively pushing icy comets out of the Oort cloud, many of which reach diameters of several kilometers, and this already poses a serious threat to Earth. If such a giant decides to visit our planet, humanity will not be able to avoid an irreparable catastrophe. Catastrophic consequences for Earth's biosphere are also associated with the star Nemesis, which is believed to be the Sun's invisible companion. Don't be quick to frown sarcastically, because every hypothesis deserves consideration. At the end of the 20th century, paleontologists David Raup and Jeb Sepkoski proposed a theory on the statistical periodicity of species extinction on Earth. They determined an interval of 26 million years. That is, after the specified period, a complete reset of Earth's biome inevitably occurs through its total extinction. According to their research, there have been 12 such events in the last 250 million years. What is the reason for this? Paleontologists believe that the culprit is the Sun's companion star, Nemesis. By the way, it's also called the Death Star, as they say greetings to Darth Vader. Nemesis is presumably a red or brown dwarf, which is currently about 1.5 light years away from the Sun. Where did these numbers come from? When making his calculations, the follower of the theory, Richard Muller, refers to the most recent mass extinction, which occurred about 5 million years ago. As evidence for the existence of Nemesis, scientists cite the fact that half of the main sequence stars are binaries. So why should the Sun be an exception? This explains the changes in the orbits of some trans-Neptunian objects, such as Sedna. Astronomers claim that it is in resonance with Nemesis. Otherwise, we simply wouldn't be able to observe the dwarf planet where it is now. Will we be able to detect the elusive star that influences many stars, even the survival of organisms on Earth? To do this, we need to analyze the data collected by observatories, which could take several years. Finally, it's worth mentioning another significant study organized by Michael Brown and Konstantin Batygin, a Russian astrophysicist. Initially, they set out to debunk the myth of Planet X, but in the process, they realized there was plenty of reason to believe in it. For example, the astrophysicists tried to refute claims based on research from the Wide Field Infrared Survey Explorer Orbital Observatory, saying that no object comparable to Jupiter or a star resembling Nemesis was found near the Sun. Michael and Konstantin refer to the fact that the orbits of some trans-Neptunian objects are aligned in the same way, and this is reflected in the results provided by the telescope. So, there must be some celestial body that contributed to this, but why didn't the telescope find it? Konstantin Batygin and Michael Brown, who is called the executioner of Pluto, because it was thanks to him that the planet was demoted. The dwarfs explain this by saying that the object is too small, no more than 5 or 10 Earth masses. They came to this conclusion with the help of computer modeling. But maybe all of this is just fantasy and speculation? After all, throughout the history of human civilization, people have most often been attracted to imaginary phenomena, non-existent gods, supernatural forces, or magical abilities. As a result, far less time was spent on real things. Perhaps Planet X, the Nemesis star, Tyche, and the elusive black hole all belong to the realm of phantasmagoria, existing only in the imagination of certain scientists. What do you think about this? Share your thoughts in the comments and don't forget to like the video if you enjoyed it.